Where am I? I'm on Mars. Yep, you heard me. Mars. Having an average temperature of negative 62 degrees Celsius, having only 1% of the Earth's atmosphere, and receiving 30 times more radiation, it's as uninhabitable as it can get. But did you know that Mars used to be like Earth? Around 4.6 billion years ago, Mars was an entirely different world. The planet had water, a thick atmosphere, and a warm climate. And this leads us to the big question: why did Mars change? To answer this, let's go back 4.2 billion years. In our solar system, the sun constantly emits something called solar wind. Solar wind comes from the sun's surface and is primarily made of protons and electrons that come from ionized hydrogen, which is when a hydrogen atom loses its electron to form these components. These energized particles travel around 1,000,000 miles per hour and are capable of stripping away the atmospheres of planets and thus any life and water within it. Then how come Earth is safe? You see, Earth's secret weapon is its magnetic field. The magnetic field acts as a barrier, deflecting any solar wind heading towards our planet. Similar to Earth, Mars also had a magnetic field, which is why the planet had these livable conditions, until it disappeared, becoming the Mars we know today. You see, magnetic fields are powered by a geodynamo inside the planet's core, and for this to happen, 3 conditions must be met. There has to be the right amount of heat, movement, and material, and they're all interconnected, meaning that if one fails, the whole process falls apart. Let's use Earth as an example. Earth's core is divided into a solid inner core and a liquid outer core. The inner core powers this whole process through radioactive decay, releasing an extraordinary amount of heat. This heat is so hot that when it reaches the outer core, movement occurs in the form of convection because of the differences in temperature. The hotter, less dense material rises, and the cooler, dense material sinks. Earth's core is also made up of the right material, iron, because it's a good conductor of electricity and also ferromagnetic. You see, magnets have magnetic field lines, and when they're removed and pass through atoms, they can break off electrons, which can then create a chain reaction of moving electrons, forming a current. In short, moving magnets produce an electric current. So, as the iron undergoes movement in the outer core, a current is created, which then produces a magnetic field, and the same process can be seen inside this electromagnet. When I run a current through this iron nail, we can see that a magnetic field is created due to the direction change in this compass. Because the nail is ferromagnetic, it is made up of many individual domains that are randomly oriented. But in the presence of this current, the domains all line up to form a much stronger magnetic field. Now, this entire process is called the geodynamo. Going back to Mars, the reason why the planet lost its magnetic field is because it was farther away from the sun and half the size compared to Earth. Because of this, the planet's core cooled quicker and eventually lacked the heat to drive the entire process. And yes, Earth's core will eventually cool, including every other planet, but luckily for us, that's a problem billions of years in the future. In the meantime, just remember that our planet's geodynamo is just another reason why we're able to exist.